And these next two problems are going to be the worst of it. And I look at this and I say, I have two things. I have this squared thing, which I can't do anything with. So if I normally look at natural log, we said, oh, well, I can bring the 2 down in front. Can't do that because it's that whole natural log that's squared. So that says that thing is natural log times natural log. Can't do anything with it. So my two things are just dx and natural log of x quantity squared. Well, if that's dx, that's got to be integrated, which means that this is the thing that's left to be differentiated. And here's the problem. When I differentiate it, does it go away? It's 2 times the blob times the derivative of the blob. The blob is natural log of x. It's not going to go away. But I got to do what you got to do, and this is my only choice. So u is going to be the natural log of x, the quantity squared, so that du is 2 times the natural log of x times the derivative of the natural log of x, which is 1 over x dx. dv is just dx, so that v is equal to x. So that says the original integral, which is the natural log of x, the quantity squared, dx, is u times v. U is the natural log of x, the quantity squared, times v, which is x, minus the integral of v, which is x, times du, which is 2, natural log of x, times 1 over x dx. So remember what I did is I 7'd it. Now I clean it up, so this is x, I like that in front, natural log of x, the quantity squared, minus the integral of, well, x times 1 over x, those reduce out. So I'm left with 2 natural log of x dx. Is 2 natural log of x integrable? In other words, is it a basic? Is it a basic? No. But how could I integrate this? We've done this one before. By beginning with a P, A, parts. By parts again. On that I have to put a frowny face. So what I'm going to do, this is x, natural log of x squared minus, and there's going to be a bunch of stuff after that, so here we go. I am going to do what's normally called an aside, but I'm going to use the bottom part of the page, like the bottom third, and instead of doing an aside, I'm going to do on a bottom. Because I can't do it to the side. Otherwise, it would be an aside if I did it to the side. But since it's at the bottom, we have to do on a bottom. So what do I want to do? I want to do the integral of, and I'm going to take the 2 along. The 2 is going to multiply in the end. The natural log of x dx. And this is going to be by parts. So, what's u going to be? And dv. What's u? Natural log x, because he has to go away, right? It's my only choice. So that du is equal to 1 over x dx. And dv is just dx. So remember, we take this thing and use it all up. So that's going to be u. What's left over is dx, so that has to be dv. So the whole integrand is used.
Wasn't it 2 on the next?
And we'll bring 2 back up. The 2 is just a constant. You could bring it down if you wanted to. And v is just x. So now we 7 it. Pardon me? Oh, I'm sorry. Thank you. So this is u times v. So u times v, x, natural log of x, minus the integral of v du, x times 1 over x dx. Now notice what happens with these guys. They become a 1. So this is x, natural log of x, minus the integral of 1 dx, which is x, natural log of x, minus the integral of 1 is x, plus c. And that I'm going to bring back up and place in the others. So you guys get caught up. And so that says this then becomes 2. That's the 2 from this integral. And that's going to multiply everything, which is x, natural log of x, plus x, plus c. So this becomes x, natural log of x squared, minus, well, I say I multiply that through. I don't know, multiply that through. Minus 2 times x, natural log of x plus x, plus, or not the plus x, that's a minus x, isn't it?
Mm-hmm.
White tape, white tape. See, I don't like minuses, so I avoid them. Now, if you want to multiply that 2 through, you can. But I don't know about you. I'm lazy, so I'll do it just for the heck of it. And then that should be like that. Minus 2x, natural log of x, plus 2x plus c. I don't do parts, if I have to do parts twice, I don't do it in line. I don't come back, I don't do it as part of that original problem. I move it to the side, work it all out, and then bring it back. Because I find it's far too complicated to try to do that. U substitution's the same way. You've got a problem that's got multiple things, then it's much better to work it in pieces and then kind of separately and then bring it back together again. So you don't get U's all confused and other stuff all confused with what you're doing.